Hello, everybody. We've got Keith Wiley here today, and we're going to be talking about mind uploading, whole brain emulation, and an up-and-coming workshop put on by Carboncopies in the near future. So, yes, by way of introduction, Keith Wiley has actually written a book on the topic of the taxonomy of whole brain emulation, and has been researching these subjects for quite a while, and hence I've got him here to discuss the up-and-coming event and the topic of mind uploading again, which is always a fun topic to talk about. But just for those who are not initiated in the subject yet, what is mind uploading and whole brain emulation, Keith?
So whole brain emulation is basically our attempt to figure out what parts of the brain, both functionally and sort of structurally, are necessary if we want to create computational models of the brain that, when those models are then run on some sort of advanced computer, will represent a valid emulation of the original brain, and by association of the mind that was on that brain. So a whole brain emulation is an entire brain emulated in all of its different sort of cognitive functions, in order to essentially to put a spin on it, to sort of continue a person's mind in a computational emulation of their brain. Mind uploading is not too far removed from that. It just is a little bit less ambiguous about the intent. Whole brain emulation is about the sort of the method and the scientific underpinnings of trying to emulate a brain, but it doesn't necessarily state some sort of personal goal. Mind uploading is sort of the application of whole brain emulation toward the specific intentional goal of preserving your mind and your personality and your personhood across this procedure in which the function of your mind discontinues from brain and continues in some computational system.
Right. I mean, this sounds pretty sci-fi to a lot of people, I imagine. But in what way would you describe this procedure to somebody who was relatively uninitiated or had no idea about it in an elevator over a minute?
Yeah, I do need to work on my elevator pitch. Basically, it starts with the assumption that our minds are completely based on the physical properties of the brain, and if you assume that the brain's purely physical properties underpin the mind, then there's really nothing in theory that prevents us from continuing that process elsewhere. So that merely leaves open the question of sort of why and what the point is, but it sort of already settles the question of whether it should be feasible. Sort of the assumption of physicalism and functionalism and materialism sort of leaves you sort of in this position of being ready to move forward with sort of questioning, how it might be useful. And then, why people want to do this, everyone has a different answer. Some people are interested in using it sort of as a method to sort of extend longevity in ways that biological human bodies are sort of difficult to repair beyond a certain limit. But other people don't see sort of longevity as the primary goal. That would just be a secondary effect. Other reasons to use to basically get our minds into an emulated sort of substrate, an emulated computational system, is because that just gives us better access to this brain, or this computerized version of the brain. Once we have better access to it, we can do interesting things with it that are just really hard in the wetware of the brain. So we should be able to repair a number of the diseases that are physiological in nature. We will continue to make inroads on, but some of our diseases are just they're basically psychological diseases. They represent ways in which the brain's wiring is probably problematic, and you can try to change that wiring in the wetware, but once it's emulated, once it's computational, we can change the wiring in that computational system probably more easily. And then beyond that, the other sort of purpose is in this this realm of how we can really extend the human experience. What are the things that we can enable human minds to do that are really hard when they're trapped inside brains? So, there are a variety of examples that come up frequently, enabling people to access sensory modalities that we don't readily have. So seeing infrared and ultraviolet and hearing ultrasonics and frequencies, things like that. Well, let me see. So other animals can sense the magnetic sense, or they can see the what's it called? The polarization of light. And then there are the sort of the mental experiences that we might get, which then comes into, again, by having this direct access to the computer on which a mind is running, we might be able to more easily facilitate sort of direct communication between minds, whether you want to, the colorful word for things like, telepathy is the colorful word, but telepathy always sort of inspires reaching outside of science. And the whole point of taking the whole brain emulation approach to this is that everything we're concentrating on in these research efforts is squarely focused on what physicalist science enables. There's really no supernatural element to it. It's far-reaching in the remarkable level of scientific detail and engineering detail, the bioengineering detail that is required, but it sits entirely within naturalistic science.
Yeah, so I mean, by physicalism and what some people mean by materialism, it's just talking about obeying the same laws as the rest of the physical universe. So physics, there's nothing like supernatural about how our mind works. Given a the mainstream, almost materialist view on how our mind works and how the rest of the universe works, it should be in theory possible to do this sort of thing, given the right knowledge and the right engineering to do so. Is that correct?
Yes, I mean this is sort of the basis of sort of the majority of science is basically that we're only within science we're only going to even attempt to investigate claims of phenomena that are sort of accessible to physical inquiry. If we can't see and observe and measure and tweak and study something within the sort of physical sort of channels that we have access to, then we're not going to worry about it. So if people make claims about non-scientific or quasi-supernatural sort of events and forces, then that lies sort of outside scientific scrutiny, and we don't really concern ourselves with that within science. So the hard part of whole brain emulation and mind uploading is trying to convince people that we are, our intent, our goal, our approach is utterly physical and functional, and we're not really looking for any sort of magic here. We're just trying to see what the further limits of science are beyond our capability in this particular year of history. What should be accessible as science and as technology and sort of engineering capability continues to advance.
That's correct. Well, the topic of this workshop is it really focused around the engineering and the science and the actual technological roadmap to the whole brain emulation or mind uploading. It's not really about the social ramifications or anything like that at this stage. And these topics are very important as well. But in order to keep on the technology, the main driver of this online discussion, which will be on the 28th of January or something like that, is that correct?
That is right. Sunday the 28th.
Yes.
The 28th. And that's
a lot of time. Okay, so I've talked to Randall, and he's going to update the website there, which is going to be linked to from the description here for the GMT time. So people can log in to the Hangout on air or the live stream and watch and even participate that way as well. And I think there'll be quite a lot of people doing that. So so. I know a number of people in Melbourne will be. Yeah, so that'll be good.
Yes, we're really excited about this. As you said, there are many different sort of topics that come up. this workshop is not overly focused on the the big metaphysical philosophical quandaries of identity and whether uploads are conscious and whether uploads are true continuations of identity as opposed to copies, which is the main thrust of my own writing, is basically tackling and attacking the copy problem, because I think it's not actually a genuine problem. But the point is, this workshop is not focused on those philosophical aspects. It's also not focused deeply on the social aspects. Some people ask, the questions of why or whether a society should want to pursue this, from sort of the goal-oriented point of view. Is this something to do? The point of this workshop is to bring the public up to date on the latest, most exciting sort of state of science and state of engineering and state of sort of our continuing understanding of how the brain works. It's basically, let's all get together and tell everybody where we currently stand in our understanding of the brain and in our engineered and technological ability to actually alter to some extent how the brain works in some subtle ways.
Mm-hmm. So it looks as though there's going to be quite a lineup there. And now, who's this Theodore Berger chap? I've never heard of him before. How did he make it onto the schedule there, Keith?
Theodore Berger is, I believe, most widely known for his research into a hippocampal prosthesis, a prosthesis for the hippocampus. So the hippocampus is a part of the brain that is crucial in short-term memory and crucial in the transformation from short-term memory to long-term memory. And Berger has been working on this neural prosthesis. It's a device that is implanted. I actually don't know too many of the details, but it's implanted into or alongside the hippocampus, and it reads the neural signals and converts that into this sort of electrical and then signal and computational form, which basically the prosthesis is a little tiny computer. And it takes these signals and it modifies and improves and cleans up and fixes. And like I said, I actually am not overly aware of the details, but it essentially repairs or augments a damaged hippocampus, and it takes the input signals, it repairs them, and it feeds those signals repaired back into the hippocampus. And I'm about to speak outside my depth, but my understanding, if I recall, is that it helps improve damaged short-term memory, and that's what Berger is most well known for.
Mm-hmm. Yeah, so he's quite well known within the neuroscience community too. He's won some awards and stuff, so that'll be great.
Yes.
We also have, of course, Randall. He's going to be sort of helming the event, and Diana Decker as well, and a number of people. So let's talk about some of the people and the topics which are going to be discussed. Well, I'm going to leave it up to you really to decide what to discuss. I mean, we already know that mind uploading is going to be spoken about. The roadmap, where we're up to so far. And kernel and neural links. We got a cat.
Yes, my cat's going to run across the desk a few times, I suspect. Yes, there's a discussion of two companies that have really come into the media in the last year or so. One is Kernel, which is developing neural prostheses, at least in part inspired by Berger's work. I'm not sure exactly what all of Kernel's projects are, but they're definitely basically trying to build out those kinds of devices in a from a sort of business-oriented point of view, as opposed to as part of government research projects. And the other big one is Neuralink, which is famously associated with Elon Musk.
Yes.
And the what's it called? The neural lace. And they're trying to create brain-computer interfaces, and we will learn and hear about how both of those companies and their projects are progressing.
Interesting. So what are your thoughts on how they're progressing? What's your personal view? You think they're the right approaches or the wrong approaches, or somewhat right or somewhat wrong? What do you think the outcome might look like within another 5 to 10 years?
Well,
that's okay. Cats are cute. Cats in YouTube videos increase
yes,
views.
now it's a proper internet video. It's had a cat in it. Well, what I've always liked about Berger's work is that he's really trying to he's found this medical application that could really assist people who are in a sense suffering, who basically have a damage in this part of their brain that is causing really a lot of trouble in their life. And it is an excellent proof of concept that we can circumvent broken parts of the brain with computational prostheses. And there's the question is sort of the sky's the limit. What sort of damaged brain features can we build prostheses that work in this way, that actually take neural signals and process them computationally and feed those process signals back elsewhere into the brain and essentially do an end run around damaged components of the brain. So I like the approach because it the sort of the inherent goodwill of that approach is just sort of irrefutable, and it gives us an easy inroad to the further advances that should be possible. As for Neuralink, I'm not as aware of sort of the intended applications. I know that the goal is to create brain-computer interfaces that enable the interactions between computers and brains. But actually, I'm looking forward to the workshop myself. For I intend to learn a lot from the workshop. I don't enter into this workshop sort of knowing everything is going to be presented, and I'm hoping to learn a lot about it too.
Yeah, me too. Actually, yeah, it's great to attend these sorts of things because you get to network with people who have similar interests. And at the moment, it may seem so interested parties are really like on the fringe of a mainstream discussion in general neuroscience, but it seems as though engineering applications for this sort of thing are just going to grow and grow. The more we understand it, the more these types of inroads to these sorts of technologies become, I guess, more publicly accepted and more feasible in the general mainstream of the scientific community for one, and then general community for the next. But
I agree.
People who are obviously loom large in the imagination of many, like Elon Musk. He's quite a well-known chap, and he's very visionary. And we need visionary people to be able to push the boundaries of what we can actually achieve in science and technology, especially neuroscience. There, and it's these visionaries who often the ones who really get the ball rolling and kickstart some really revolutionary changes in the technology there. And yes, as you were saying, it seems as though there's a lot of altruistic reasons for this type of technology. A lot of people suffer needlessly because of either brain damage or because they have some sort of a condition which could be alleviated with some drugs, but would be more, I guess, more accurately or more like a fine-tuned type of approach to solving some of the depressions and the anxieties and the mental so-called disorders that people have.
Well, and the other thing about it is that we often think of brain disorders in terms of chemical imbalances, but if you take an information processing approach to how brains work and what brains are doing, then it all comes down to signal processing and information processing on some level. All a chemical imbalance really is the chemical physical underpinning of flaws in the information processing parts of the brain. The reason that the brain exhibits a behavioral abnormality is that it is firing the wrong signals between the neurons. Now, the cause might be chemical in nature, but the real error isn't that the chemicals are the problem. The error is that these signals transmitting through the network are the problem. So again, if you have this really sort of information-inspired approach to the whole thing, then you start wondering whether the best way to fix problems in the brain is just go at the information processing pathways in the first place. This is very difficult to do in the biological wetware. To tweak directly with the way the signals are propagated, you have to do something sort of like what Berger's prosthesis does. You have to put these electrodes in and sort of retrieve the signals from the neurons and put them through some computational algorithm, which then feeds electrical signals back out, microscopic probes to other neurons. You're really sort of dealing with the wetware in order to get to the signal processing. So this all comes right back to whole brain emulation. If we can basically get all of this kind of out of the biological system and into a computational system, then we can interact directly with the signal processing aspects, the information processing behavior of the brain. We don't really have to worry about how chemicals cause that to happen in a biological system. We can just go directly to what is essentially neural network processing, figure out how the network is misbehaving and make the network behave right. Now, again, when I say things like this, a lot of people hear this and their reaction is that's also futuristically outlandish, that it's sort of beyond consideration. But certainly at Carboncopies, there are many different groups which have different approaches to futurism. But Carboncopies is a group that is we don't really have what some people might characterize as outrageous timelines. We're focused on the sort of the long-term goal and building out the research and building out sort of as much as possible a popular acceptance that sort of this basic philosophy, this basic approach to what brains are and how brains work, is sort of a good long-term approach to neuroscience. And it might sound crazy to think about emulating an entire brain and then getting direct access to the information processing, but it's not crazy if you don't really put any specific date on it, if you're just sort of motivated by the underlying goal. And sort of speaking for myself, not necessarily speaking for every member of the organization, but certainly my personal take on it is that I don't obsess over specific dates, and I'm interested in just making sure that the field as a whole gains steadily increasing acceptance and makes steadily increasing sort of scientific progress.
Yeah, and it's worthy of note, it's hard to put a date on these sorts of things. Popper once said that we cannot know what we'll discover tomorrow, but I don't think it's completely beyond the pale to make guesses. What we've seen so far is, like with progress in AI, for instance, people have been continuously surprised at what's going on, like within the company DeepMind, and the sorts of engineering challenges that AI has been able to solve. And I expect that to continue in AI, and I also expect that to continue within the neurosciences, and specifically the whole brain emulation or neuroprosthesis arena as well. Look, I don't hazard a guess on as to dates, but like I've got my own personal sort of views about timelines which fluctuate based on, I guess, progress in the actual science, and that's why this is a good workshop to attend, and it's an excellent one to contribute to because and to sort of build the discussion around, because it's talking about the real progress, analysis on what's actually being done in the real world on the ground now, which should be used to inform our estimates of what kinds of technologies we can develop along the roadmap to these longer-term goals. So it's very exciting.
Yes. Right. So insofar as this interview is primarily to promote the workshop and gain some access for it, gain some attention for it, I'm not sure what else to say. I want to I want to sort of encourage anyone in the public to join in, even if they don't know much about this. So let me just sort of preface that the format is intended for people, sort of across a broad range of experience, but it's definitely designed to be intended to people who know next to nothing about this. The opening presentation will be an absolute rank introduction to the entire topic. It will be accessible to anyone who wants to sit in and sort of learn the basics. The sort of update on state of the art of science and engineering will certainly be intended to be, again, accessible. Again, it should be sort of it won't be like sitting in an academic conference and listening to people sort of speak at the level of their sort of internal community of neuroscience researchers. The intent is definitely that anyone should be able to observe and listen and get useful sort of knowledge that they can take away from it. And each of the major sessions of the workshop will be followed by a public Q&A. There will be an in-person, an on-site location in the Bay Area, but we expect the majority of the participants to be basically joining by video. I will be joining by video because I live in Seattle. So the public is invited and encouraged to actually actively participate. We really hope that the presentations basically spur a conversation during the Q&A period, and that's definitely our intent, is to bring more people into this area and into the conversation.
Yeah, that's right. Yeah, it certainly does look as though, looking at the agenda here, and if anybody's interested, they should really look at the agenda, because it's on the link, which I'm providing a description here. But it does start out with an introductory preface to what all this is. In the first hour, which is really what is the mind uploading and why humanity needs it. Then from there, it's a discussion on the technologies and the roadmaps. And finally, yes, at the end, there'll be Q&A where people can sort of bring up their own topics for discussion, or, ask questions about what's being spoken. I think, which is when the speakers will have their lunch, there's also going to be more of an open discussion. So there's a couple of times during the day where I think people have access to bring up their ideas and participate as well. I'm not sure if there'll be time for question and answers after each specific talk, but who knows? Yeah, we'll see what happens.
Yeah. So what else can I tell? What do you think what else would your viewers like to know that would sort of encourage them to join in?
There's a variety of different kinds of people who are going to be joining the discussion. And I've spoken to people who are interested in following, doing some neuroscience, who have a bit of a transhumanist background, who believe that the long run is worth looking at, and looking at some of the ideas around mind uploading and some of the longer term possibilities there. And then people who just don't know what it's about and have just heard about this from Elon Musk's company Neuralink going viral on the internet, and general discussions around that. People who have seen these ideas or sort of crop up in plot arcs in movies even. All this is very interesting too for everybody, but they want questions about where the technologies are now, or what kinds of technologies are around today, and they'd like to see some expert opinion on where it's going to lead into the near, medium, and long term. So I think there's a variety of people there. What will people like? I guess one thing I didn't notice on the website there was a link to an area where people could submit possible questions before the event, because maybe people are looking at this from a completely different angle than the people speaking. And
that's a great recommendation.
There could be a link to a discussion on Facebook or an online forum. Doesn't have to be specifically.
Carboncopies does have a Facebook group.
Yeah,
So
and we
certainly in lieu of the fact that we didn't implement what you recommended, there isn't a specific link on the website that sort of takes submitted questions. That's a good idea. It might be too last minute for us to do it, even though it's such a good idea. But the Carbon Copies Facebook group would be one place to drop questions like that.
sure.
Yeah.
Now, not everybody's on Facebook, but I mean, a lot of people are. And I'm not sure if there are any other resources that people can do this with. But this is also, of course, the great area for people to continue the discussion after the event is over as well. But I'll provide a link to that group in the description of the video. If anybody's interested, please join and be part of the discussion there as well.
Yeah.
All right. Well, it's been fantastic talking to you again, Keith. It's always great to have you on the show.
Yes, you and I haven't spoken in a while. It's good to catch up.
Yeah, that's right. So I'm looking forward to joining this event. I'll probably see you in line there too.
Yeah.
So onwards and upwards. Here's to the future of mind uploading. Wow.
Thank you very much for your time.
My pleasure. And thanks everybody for joining in and listening. Speak to you soon.